Now in this last module of our class, before in module 26, we looked at the R value, the correlation coefficient that'll tell you, okay, if I think our data lines up in a nice line, it's I think a linear model will work. It measures how strong the strength is or how closely it comes to a line. In this module, however, we'll actually look at that line. We'll use a line to make predictions. That's what we're trying to do. I want to figure out what that line is. Usually, of course, technology is going to do it, not us. In this section, we will focus on a line as a statistical model. A statistical model is a mathematical equation that summarizes the pattern in the data, taking variability into account. As you know, measuring variability is at the heart of statistics. So statistics models come with assessments of how well the model fits the data and also the average amount of error. Why do statisticians create mathematical models to summarize data? The primary motivation is to make predictions. So we will start by making predictions using linear models. As you work through this example, focus on how we use the graph of the line and the equation of the line to make predictions. Don't worry so much about how we get the line's equation. We will discuss that soon. Now we're looking at an example where we're going to use a line's graph and its equation to make predictions. Earlier, we examined the linear relationship between the age of a driver and the maximum distance at which the driver can read a highway sign. Suppose we want to predict the maximum distance that a 60-year-old can drive and can read, a 60-year-old driver can read on a highway sign. In the original data set, we do not have a 60-year-old driver, and there is variability in the data. So how do we make a prediction? Here again is the scatter plot of drivers' ages and maximum reading distance. We marked 60 on the x-axis. Let's scroll down and look at that now. So yeah, notice 60 on the x-axis. Here, if I kind of go up, I don't see any data values that are even really that close to 60. Oh, I went a little bit too far. Yeah, but we'd like to know about where it is. I mean, I'm imagining they're going to be somewhere around here that looks like if there's a line that fits the data, it's something like that. So we're going to figure out what that line is. That's what we would like to do. The function should look like mx plus b. Remember slope and y-intercept and all that. Slope is m, y-intercept is this guy. If we figure out what those are, the slope and y-intercept, we can figure out what the equation of the line is, and then we should be able to figure out what kind of data values will come next. Of course, different 60-year-olds will have different maximum reading distances. We expect variability among individuals, but here our goal is to make a prediction that follows the general pattern of the data. Using the graph of the linear model to make a prediction. Our first step is to model the pattern in the data with a line. In the scatter plot, you see a red line that follows the pattern in the data. Later, we will learn how to find the best line for summarizing the pattern. Oops. Let's go look at that now. I'm going to clear these drawings so we can move down. Okay. That line, we'll try to use that line to predict. Imagine that's already been found for us. So, or usually technology will find it for us. It looks like, who knows what it looks like? Y equals mx plus b. Slope would be negative because it's sloping downward from left to right. Anyway, for 60-year-old, let's just try to see, okay, 60 would be about here. If I try to make a vertical line, just so I see where it lines up with the red line, I'm going to try to figure out what point that is. It looks like maybe it's around 40 or a little less. So I would say a 60-year-old can probably see, or sorry, 400 feet in front of them, maybe. So to use this line to make a prediction, we find the point on the line with an x value of 60. We simply trace from 60 straight up to the line. We use the y value of this point as the predicted maximum reading distance for a 60-year-old. We trace from this point straight across to the y-axis and just kind of try to see about what point on the y-axis it is. It looks a little less than 400, like we said when we did it. Just under 400 feet, using the equation of the linear model to make a prediction. So now we can also use the equation of the line to make a prediction. Usually technology finds the equation of the line for us because it's usually not a pretty number for the slope and the y-intercept. The predicted distance would be 576 minus 3 times the person's age. So, if you remember the mx plus b thing, mx plus b, it looks like this is our mx, our slope is -3, and then our y-intercept is 576. So if I wanted to know what about a 60-year-old, x represents the age of a person, so I'm going to put 60 in there for x. -3 times 60 plus 576, so this would be -180 plus 576. And those added together should give you the answer, 396 feet. Soon we'll learn how to use StatCrunch to find the equation of the line that best fits the data. Like we said, we could probably do it ourselves, but it would be very tedious. Later, we develop a method to measure the accuracy of the prediction from this best line, quote unquote. For now, we'll just focus on how to use the line to make predictions.